Hi, my name is Krishna, and this is my 15-112 term project. It's called Puzzle Mania. So there are two main components to this game. One is the constructor, and one is the solver. So let's look at the instructions. So the constructor has two features. One is the puzzle maker, and one is the grid maker. So in the puzzle, the constructor creates a puzzle from an image, shuffles the pieces, and lets the user solve the puzzle, much like a jigsaw puzzle. And then for the grid, the program makes a grid-like puzzle, and the user can select two pieces to switch their position on the dashboard. So for each game, there are hints available, and there are 3 different levels. For easy, there are big pieces. For medium, there are smaller pieces. For difficult, there are even smaller pieces, but with different dimensions. Yeah, so let's see how these work. Let's start with the puzzle. And so the user can upload their own picture if they like, and the program will make a puzzle for them. But or they can pick from the existing picture library. So let's start with an easy puzzle. So here the user can click, drag, and drop the piece in the dashboard. If it's somewhere close to the right location, it will snap into place. If it's not, it will just stay there and the user can drag and drop again. So let's look at a harder version of the puzzle. So in this case, as you can see, there are smaller pieces with different dimensions, and the piece snapped into place. Here I can ask for hints if I need any. Yeah, so this is the puzzle constructor. Let's look at the grid constructor. So the first level is easy. So here the program makes a grid-like puzzle, so the user can pick between any 2 pieces and they will switch. Yeah. Let's look at the next level. Here the pieces are much smaller, and the user can pick between 2 locations anywhere on the dashboard to switch the pieces. And there is a hint provided, which is the final image. It will display for 10 seconds, so the users can have a look at it. And then the game resumes. For the hard version of this game, the piece can only be switched with the adjacent pieces or pieces that are directly diagonal to it. So for example, these 2 can be switched, and these 2, and these 2, but these 2 cannot be switched, and an error message will pop up which will say not a valid move. This also has a hint. Yeah, so that is the constructor part of my project. The next one is the solver. So let's look at the instructions. So for solver, the user can upload the final image of the puzzle and also upload a picture of the shuffled pieces on a plain white surface, and the program will use Python imaging library PIL to do some thresholding, edge detection, and color detection to solve the puzzle and number them in consecutive order from left to right and top to bottom. So let's see how this works. So here I will upload the final image. See final C. Here shuffled, open. So it takes a few seconds. And here it is. So here is the final image with the numbers on it from 1 to 12, and here are the shuffled pieces. So as you can see, some of the pieces are well matched, some are close, and some are not so close. So 4 is match, 2 is not a match, it's pretty close though, 6 is close, 3 is close, 9 is a match, 11 is a match, 7 is pretty close, and 8 is a match. So let's see how this program does this. So first thing it does is it uses thresholding. So it makes everything that is not a piece, as in the background, white and the pieces black. And then from there, it uses gradient difference between black and white to detect the edges like so. And from the edges, it is able to cut the pieces up, individual pieces like this, and also cut the final piece just by the number of shuffled pieces available. And then it compares the average pixel number in all the pieces, all the final pieces and all the shuffled pieces, and then it matches the shuffled pieces to the final image. Yeah, so that is my term project. Thank you for watching.